Okay, hi. So good morning, everyone. Thank you so much for coming to my session. My name is Alba Azcona. I work as an architecture lead for Financial Force, and I'm also a Salesforce MVP and the South Spain developer group leader. This is my email and my Twitter handle in case that you want to contact me later. First of all, I want to give you a quick introduction about my company. My company, Financial Force, has the #1 ERP over Salesforce. We have applications for financial management, professional services, billing, and much more. We are more than 700 employees, and we have offices in many places, as for example in San Francisco, where the main headquarters is, and in Granada, the south of Spain, where I'm based. You have come to a talk about security. But why do we have to care about security? Let me ask you a quick question. Does anybody know which is the worldwide annual cost of cybercrime in dollars? 1,000 million, 100 million, or 10,000 million? Yes? It's A, but yeah, it's a lot. Because of that reason, in Salesforce, trust is #1. If you want to publish an application on the APP Exchange, you are going to need to pass a security review. Salesforce is going to examine your code, looking for vulnerabilities or anything that you are doing that may be exploited. And in order to pass that security review, you need to be a Salesforce Security Superman. Finally, if you get to pass the security review and you publish your application in the APP Exchange, not only you, but Salesforce and your customers are going to be very, very happy because your application is going to be very, very secure. In Salesforce, there are many places in which you can configure security, many layers. But as this is a talk for developers, I'm going to focus in two main parts. The first part of the presentation is going to be about data security. I'm going to talk about object, record, and field level security. And the second part of the presentation, I'm going to talk about application security and define the different vulnerabilities that may affect Salesforce and that you have to prevent in your code base, as for example, SOQL injection, cross-site scripting, cross-site request forgery, Open Redirect, and clickjacking. And my philosophy is that nothing better than an example. Do you know these two guys? They are two MVPs. Indeed, Simon is the organizer of London's Calling, and Stephanie is just presenting in a room next to this one. And they are going to be the main characters today for my examples. Let's start with data security. First of all, I want to talk about object-level security. Object-level security is sometimes referred as CRUD. CRUD stands for create, read, update, delete. And with object-level security, you configure the create, read, update, delete permissions that a specific user may have for accessing a specific object in the organization. Let's see this with an example. Say that Simon wants to update the ACME account, which is a record that already exists in the organization, description field, through the standard UI, and say the standard UI for now. Salesforce is going to first check if Simon has update access from the U over the account table. This is going to be the first check, the object-level security check. And if Salesforce determines that Simon doesn't have access at all, the process will stop there. Object-level security is configured through profiles and permission sets. In profiles and permission sets, you are going to find an area similar to this one in which you can set up those permissions. In this example, we are giving read, create, edit, which is the same as update, and delete permissions to the armaments table, but only read permissions to the castles table. But don't get confused with these two columns on the right-hand side, because these two columns are more related to record security rather than to object security. What about if we continue with our example? Let's say that Salesforce has determined that Simon has update access over the account table. The next step will be to check if the ACME record is readable by Simon. This is known as the record level security or sharing. Sharing is set up declaratively in many places in our organization, but the default sharing model is defined in the organization-wide defaults. In the organization-wide defaults, you are going to be able to select different default sharing models for the different tables in your organization, as private, public read-only, public read-write, etc. And let's see this again with an example. Let's say that Simon is the owner, Simon is there, of the London's Calling account, and that we have selected a private sharing model for our account table. In this case, if Stephanie tries to see this record, she won't be able even to see the record. She won't be aware of the existence of this record in the organization. However, if we change the sharing model of the table to be public read-only, Stephanie will be able to see the London's Calling account, but in read-only mode. Also, we can set up the account table as public read-write, which will mean that Stephanie can read but also write in this record. But be careful with this one, because that kind of sharing model doesn't give Stephanie permissions to delete, share, or transfer the records. That's only obtained with ownership. Record level security is a really, really complex puzzle. You have to set up your most restricted configuration in the organization-wide defaults, and then you can grant extra access by using a lot of tools in the organization, as for example, ownership, role hierarchy, sharing rules, manual sharing, apex sharing, profiles, permission sets, etc., etc., etc. I'm not going to explain all of this in this presentation, but I recommend you to study this subject in depth because it's really big. But as this is a talk for developers, I want to explain something else regarding record level security. When you set up a sharing model as private or public read-only, Salesforce is going to automatically create what they call shared tables. So, for example, say that I have set up my account table as private. Salesforce is going to automatically create a table called account __ share, which you can query. And in this table, it's going to store rules of the next type. So here, for example, there is a row that says that Maria has full access to the ACME record because she is the owner of the record. But Frank has read-write access to the record because Maria has manually shared the record with him. Each time that you change sharing declaratively, the content of these tables is going to be recalculated asynchronously, so it's always going to be up to date. And the good news is that you can query and insert entries programmatically in these tables to share records with someone else. This is known as Apex Managed Sharing. Okay. What about continuing with our example, the next layer of security? The next layer of security is going to be FLS checks or field level security. If we have surpassed the object level security layer, we have surpassed the record security layer, then Salesforce is going to check if the fields that we are trying to modify or read are readable or readable by a certain user. In our example, it's going to check if the description field is editable by Simon. FLS is much simpler than record level security because it can be set up also at profiles and permission set level. You are going to have two columns to set up read access, edit access, and if you uncheck both boxes, the field simply will be hidden. But again, I want to give some more information for developers. CRUD and FLS data model is stored behind the scenes in tables that you can query as well. So you can see here that each user can have a profile assigned, can have several permission sets assigned, and each permission set is going to have some system permissions, assigns, etc., but also the object permissions and the field permissions. This is the CRUD and this is the FLS. And do you know why we don't have arrows from profile directly to object and field permissions? Because Salesforce is going to store a mirror profile in the permission set table for each profile that you define in the organization. If you need to query these tables, you can do it, but Apex provides some utility methods that we will see later, and which you can use as well to check for a user CRUD and FLS permissions, and which won't count towards the limits. Finally, I want to talk about a very handy table called user record access. These tables summarize the CRUD and sharing permissions for a user and a record. You can do the queries in these tables of the kind, give me which access level does this user have over this specific record. But it's a bit limited because you couldn't ask, for example, give me all the users who have permissions to this record. You always have to specify a user ID and a record ID. And also, it's needed that the user that performs the query has visibility over the records. If you are a system administrator, you will be able to query anyone's permissions. Now that I have defined what's object, field, and record level security about, I want to talk about user mode and system mode. When Salesforce created these three-layer security checks, they thought that it was a good idea to enforce automatically those permissions in most of the cases. This is when users are interacting through the standard UI, when they are doing a standard API call, using execute anonymous, which uses the tooling API under the scenes, and in most of the cases in Visualforce pages. But they wanted to also give developers the ability to skip these checks when needed, because developers usually have to create system processes and skip those permissions. For that reason, Apex classes, Apex triggers, Apex web services, and Lightning components don't enforce these three-level data security permissions automatically. So, if you want to pass the security review successfully, you will need to either enforce those permissions in this system mode or explain to Salesforce document why you are skipping those permissions specifically. This is just a clarification of what I say about the Visualforce pages. If you are using a standard controller or a standard object notation, as here that we are accessing a field directly, in that case the security is going to be enforced. But if you are accessing some info defined in the Apex controller, for example, in this case we are accessing a property, in this case the Apex controller system context wins, and it's not, the security won't be automatically enforced. But I have explained what's the security about. I have said that we have to enforce it in system mode, but how can we do it? Well, it's not very difficult, okay? What you have to do, well, remember when I explained the CRUD and FLS data model, I said that there are some Apex utility methods that you can use. Are those methods here? What you have to do if you want to enforce a CRUD in system mode is to check if a table or object is accessible before querying, is creatable before inserting, is updatable before updating, and is deletable before deleting. For fields, it's very similar. You may get confused because when you define field level security, you define if a field is readable and writable. But when you query for those permissions in your code base, you will use a method which is called accessible, creatable, updatable. Why? Because a field, well, in most of the cases, is creatable and is updatable, is going to return exactly the same value, but there are cases in which that's not true. For example, let's say that we have a lookup field that doesn't allow reparenting. That one will be creatable but not updatable. Finally, a tip here is that if you do the FLS checks, the CRUD checks are going to be implicit. You don't have to do both. And what about sharing? For enforcing sharing, what you have to do is to annotate your classes with a clause that says with sharing. But be careful with this because sharing is a much more complicated concept. Because if you use with sharing, that will mean that the record security will be enforced in that class. You can skip those checks specifically using without sharing, which will mean this is a system process, I don't want to enforce sharing here. But if you don't specify anything, the security will be inherited from the caller, and more complex schemes may appear. If you don't specify sharing in a class, and that class is an entry point, that's equivalent to have a without sharing class. A thing I want to emphasize is that with sharing has nothing to do with CRUD and FLS permissions. Most of the developers are confused with this. I don't know why, but this is very important. Even people from Salesforce have told me sometime, no, this CRUD is being enforced here, it's with sharing. And I say, no, it's not. So it has nothing to do, okay? And also related to sharing, you have to bear in mind that, for example, if you have inner classes, the behavior is different. If you have inheritance, the behavior is different, etc. But I didn't want to extend too much the talk here. Just check the documentation. So, second part of the presentation, we are fine. Application security. First of all, I want to talk about SOQL injection. SOQL injection is a very famous attack with which very famous places have been hacked. If you got to see the Game of Thrones exfiltrated chapters last year, that was possible thanks to a SOQL injection attack. Do you know the game? No? Last week I was preparing my presentation at home and my 13-year-old cousin told me, oh, I know what SOQL injection is. Do you know, cousin, that all the accounts from Geometry Dash have been hacked with that attack? And I was really surprised. So if a 13-year-old boy knows that, we are not going to be less. With this attack, what happens is that an attacker gets to trick a database operation because we are not sanitizing the user-supplied input. Let's say that in Salesforce, we have this query here. Select idea name from account, which name is like something supplied by the user. And let's say that we supply this string here. Not us, but an attacker. In that case, what will happen is that my query will be modified and we not only will be bringing accounts which name is empty, but also all our private accounts in our organization. And this is me when I noticed that that has happened. How can we prevent SOQL injection in Salesforce? Fortunately, as in Salesforce DML is separated from SOQL, is less harmful than in other languages. And also, if we are using static queries, we are completely safe. We don't have to worry about this attack as long as we are using static queries. But if you are using dynamic queries, what you have to try is to always use the colons. Because using colons, it has the same effect than using static queries. This is completely safe. The only thing that is vulnerable is when you are concatenating strings to build a query. There are some cases in which you have to specifically do that. For example, when you are using comparison operators. In those cases, there are other techniques, as for example, casting to no types. For example, if you need to pass an integer, or whitelist valid inputs. If you have a field which holds countries, just don't allow anything that's not a country. The next attack I want to talk about is cross-site scripting. There are very famous places, again, which have been hacked with this vulnerability. And with these attacks, what happens is that an attacker gets to insert an unauthorized HTML or active content, as for example JavaScript, in your web page. Well, it's really you who is showing that content to the user without correctly encoding or sanitizing it. Let's say that we have this Salesforce page here, and that the user supplies this input. If we don't sanitize the input correctly, what will happen is that this will be rendered in the end, and an evil script will be executing. However, if we modify the API's page to correctly encode those values here, finally, the string will be interpreted as a string, what we really want to do. So there are ways of avoiding this attack. How do we do this? Well, first of all, I want to mention that any user-supplied input, as anything provided by the by a URL parameter, a form, etc., is vulnerable. But also anything that comes from the backend, because it may be exported from an external system, inserted by another user, etc. So you have always to encode not only user-supplied input, but also custom fields and even custom labels. If you are rendering one of these three things in HTML code, you don't have to worry too much because there is an automatic HTML encoding layer there. What you have to do is to just don't deactivate it. Don't use escape equals false if possible, because that way you are deactivating the standard protection and making your code vulnerable. If you are in JavaScript context, or you are rendering one of these three entities in JavaScript code, the solution is to always surround by single quotes the field that you are rendering and use JS encode, as we have seen in the previous example. And when I talk about JavaScript context, it's not only the code that comes between two script tags, but also the inline JavaScript. And there are more complex use cases, as for example, imagine that you are in JavaScript code, but then that JavaScript code is modifying the DOM. In that case, you will need to first JS encode and then HTML encode. And you can use a Salesforce utility function, which is JS in HTML encode. What about Lightning components? Lightning components is the same. We have to protect user-supplied input, custom labels, and custom fields. The HTML content is not auto-encoded in Lightning components, but because of the way in which the framework is implemented, there are too few places which are vulnerable to cross-site scripting in HTML. Some exceptions are when you are setting attributes on the href or src attributes. And in this case, what Salesforce documentation suggests is to either only allow relative URLs inside Salesforce, use always private attributes so that nobody else can set values on those attributes, or sanitize these values that you are setting using an onChange event. And for JavaScript, we have the same problem as before, but in Lightning Components, we don't have the JSON code, etc. function, but Salesforce recommends to use a library called Secure Filters Library, which is JavaScript. Finally, I want to mention that cross-site scripting can affect CSS too. So never render a user-supplied input, custom field, or custom label in CSS files. The next one, the vulnerability I want to talk about is cross-site request forgery. With cross-site request forgery, what happens is, imagine this is your browser, this is your Salesforce org, you authenticate correctly with your Salesforce org, you are navigating there, and suddenly you visit a malicious website. If the malicious website knows exactly which URL or which request does your browser need to do to perform something weird in your Salesforce organization, as for example deleting all the accounts, he can force your browser to execute that request, and then in this case all your accounts will be deleted from your Salesforce org without you knowing it. This attack, you have to know two things about this attack. First of all, this is only a problem if this URL here is performing changes in the org. If it's just a request for information, it doesn't matter. And the second one is that the attacker must know exactly which is the URL that you have to write. So normally, the protection that web pages set up, as Salesforce, for example, there is a standard protection, consists of sending a token with each request and validating that token in the server. In that way, it's very, very difficult for the attacker to know exactly which URL do you have to write. In this case, my recommendation is to don't deactivate the protection, but there are, even with the standard protection activated, there is one case in which you have to pay special attention. It's on page load, because on page load, you can send the token. So you shouldn't be performing DML, because we said that doing a GET request, it's not harmful, just don't perform DML, on an Apex page action attribute, or for Lightning Components on init and after render handlers. Open Redirect. What happens with Open Redirect? Normally, if a user is navigating in your application and you redirect that user to an external page, the user may think that he's still in your application, and if that page is an attacker website, for example, sensitive information as his credentials, for instance, may be stolen. So Salesforce doesn't want you to perform arbitrary redirects to values controlled by the user. This is an example of an Open Redirect vulnerability. We are reading a parameter from the URL and we are performing a redirection to there. If that parameters is equivalent to this attacker website, we will be redirecting the user to a malicious site. So never do this. How do we stop this? Well, in my previous example, I was using the onSafe parameter, which is custom. But if you are using the standard Salesforce URL parameters, start URL, ret URL, safe URL, there is a standard protection in place. But you have to be careful because that protection is case sensitive. If you have compulsory to use custom URL parameters, then there are other techniques that you can use. For example, to only allow redirections within Salesforce, removing always the host part of the supplied input. Whitelist redirects to only allow redirections to no domains, as for example, Google or Gmail, whatever. And remember that you have to worry also about Open Redirect in JavaScript, because in JavaScript you can set up the window location attribute, and you shouldn't be setting that attribute with the user supplied input. The last attack I want to talk about is clickjacking. With clickjacking, what happens is that a user performs unwanted actions in your organization because he thinks he's interacting with something else, and it's not. It's interacting with your organization in the background. This is only possible if your pages are embeddable into an iframe. In this case, this would be your organization, which will be in a transparent iframe, and the user, if he tries to click on the Get Treasure banner, he will be, I don't know, deleting something in your organization, whatever. There is a standard protection as well that you should activate, and in Lightning Components, this protection is also there. Lightning Components are protected against clickjacking with CSP, so you don't have to worry, and it's not something deactivable or something. The only thing that you have to bear in mind as developers is that always that you develop something, do it with this protection activated, because sometimes if you are using iframes, etc., and you provide that to the end customer, and then the end customer activates the protection, your functionality is going to be broken. So always code with this protection activated. So these are my top tips for today. First of all, remember to enforce CRUD, FLS, and sharing on system mode, or at least explain to Salesforce why you are not doing it. Be very careful when passing user-supplied input into a SOQL query, because you may be vulnerable to a SOQL injection attack. Encode user-supplied input, but also fields and custom labels before using them in HTML or JavaScript code. Don't perform DML on page loads either, or with the Apex page action attribute, or with the on init and on after render handlers in Lightning Components. Don't use the user-supplied input to perform a redirection, because that could result in an Open Redirect attack. Encode your Visualforce pages and Lightning Components. Well, Lightning Components no, because it's already there, the protection, with the clickjack protection activated. Congratulations. Now you are all Salesforce Security Supermans. These are the resources I have used to prepare this presentation, especially interested in the Salesforce Security webinars. I think the slides will be there. Thank you also to Simon and Stephanie for being my main characters today. And finally, I want to talk about DreamOle, which is the community-led event that we are running in Barcelona this year, similar to London's Calling, in the 27th of April. So if you want to come, you are all invited. And that's all. Thank you very much. If you have any questions. Questions? No questions?
I had one. Is there a reason on the OWD screen that on the right-hand side it had the record sharing options, which is clearly confusing? Why is it there? Why not set up object access and then always go to sharing?
Yeah, it's a bit weird. Indeed, when I started learning Salesforce at the beginning, I thought that was completely related with object-level security. And
It's just a shortcut to save people having to do it.
I don't know, because they may have do the same in the sharing settings.
Yeah.
Because there you can set up the organization-wide defaults for each object, and they could have placed it there. I'm not sure why.
Right,
Okay, thank you.